Good morning, students. Today I am going to discuss about the line coding schema. In that, we will see one by one line coding schemas, that is unipolar, then polar. In this polar, we are going to solve for the NRZL as well as the NRZI, means non-return to zero levels as well as the non-return to inversion level. So now I am going to solve the unipolar method. Here I have taken the bits, that is 0, 1, 1, 0, 0. Then what is the 0 now? So the 0 will be a 0 voltage. So that will be a neutral, means 0 means always negative. Negative voltage, and 1 is positive voltage. So next bit is 1. So 1 will be a positive voltage. And then what is the one more next bit is 1. So it is positive. Then 0. 0 it is negative. And again 0. Yes, 0 will be a negative. Finally, we have to join all the lines together. So this is what the output of the unipolar timing diagram. Then I'll move on to the I'll see with the polar technique. In that polar NRZL and NRZI, right? I said previously what is NRZL, that is non-return to zero level. Here the non-return to zero level, I have taken the bits 0, 1, 0, 0, 1. So here what is the 0, if it is 0 means, what is the voltage? That is, it will be a 0 means it is positive voltage. Then what is the 1? 1 will be a negative voltage. So this is what the negative voltage. And then what is the 0? That is positive. 0, it is positive. 1, it will be a negative. So finally, we have to join all together. So we will get the timing diagram. So this is what the NRZL. Then what is the NRZI? In the NRZI also, so if it is the starting bit will be 0. Yes, if the starting bit will be a 0. So 0 means it will be a positive voltage. Then 1 is negative voltage. Then again 0. So 0 will be, it is going to it is going to following the previous voltage. So in the NRZI, the major thing is if it is starting bit is 0, it should be a positive, and if it is 1 means, or it should be a negative. It should be applicable only one time. So if the next time the bit will be a 0 means, it is going to following the previous previous bit output, that is means the previous bit output will be a 1. So it is negative and it is going to following the previous bit output. So now it become negative. Again if it is 0, yes, it is going to following the previous bit output, that is negative. And if it is 1 means, again until that next bit is 1, it is not changing the timing diagram. So it is always following the previous bit output. So again the final bit will be a 1. So now it is going to changing the signal as the positive. So finally we have to join all together. So we will get the output. Once again I will repeat. In the NRZI, if it is 0 means positive, 1 is negative, until that next bit is 1, it is not change the timing signal. So it is always following the previous output. So the previous output of the bit is 1 means negative. So again that bit is, the third bit will be 0. Yes, it is going to following the previous output, that is negative. Again 0 means negative. So again the fifth bit will be a 1. So during that time it is going to change the signal as the negative to positive. So this is what the NRZL. So next I will move on to the RZ, that is polar RZ. So polar RZ, which is nothing but it is a return to 0. Yes, if it is polar technique, in the polar, we are going to look at in the return to 0. So the return to 0, this polar we are going to call it as the bipolar. Bipolar method. In this bipolar we are going to look into the return to 0, differentiate Manchester and Manchester methods. These all are the different techniques we are going to use in the bipolar technique. And this return to 0, if it is 0 means it will be a low to high signal. So if it is 0, it should be a low to high, and if it is 1, it should be a high to 1, high to low. So I'll tell you one more thing. Tricks here. 0 means inverse Z, and 1 is normal Z. So if it is 0 means it is low to high. Okay, if it is 1 means that is high to low. Okay, again if it is 1, it should be a high to low. If it is 0, it is low to high. Okay, again if it is 1, it is high to low. Okay, again if it is 0, 0 means low to high. So this is what the like RZ polar. So once again I will repeat, if it is 0 means low to high. Okay, if it is 1 means it is high to low. So I'll show here in the, so I'll solve the polar RZ one more problem. If it is 0 means it should be a low to high. This is the low to high. Okay, and if it is 1, that is high to low. Okay, then again 0, 0 which is nothing but low to high. Okay, again 0, it should be a low to high. Okay, again 1, 1 it should be a high to low. So finally we have to join all together. So we will get the timing diagram. Okay, we will get the line coding digital output. So this is what the polar RZ method. Then I'll move on to the differentiate Manchester as well as the Manchester technique. In the Manchester technique, okay, if it is 0, okay, see if it is 0, it should be a normal Z, that is high to low. Okay, if it is 1, it should be a low to high. Okay, it should be a low to high. Again if it is 0, it is high to low. Again if it is 0, high to low. Okay, if it is 1, it is low to high. Okay, if it is 1, it should be a low to high. So finally we have to join all together. So we will get the line coding output. So this is what the actually like we are going to perform for the binary Manchester binary bet of the timing diagram. Now we are moving now I am going to move on to the differentiate Manchester. So in the differentiate Manchester, okay, it is the inverse of the Manchester. Okay, if it is 0 means, okay, in the Manchester, okay, we solve the high to low like timing diagram. In the differentiate Manchester, if it is 0 means it should be a low to high. Okay, again if it is 1, 1 will be a high to low. Okay, high to low. Again if it is 0, yes, it is going to it is going to following the previous bit or previous bit output until the next bit will become 1. So what is the previous bit output means, the 1 output means high to low. So it should be a high to low. So now it is going to follow in the previous bit output, that is high to low. And again the previous bit output will be a high to low. Okay, again so now it become until that next become, or it is not changing. So now now it become like right now the bit will be a 1. So it is going to changing the state, that is low to high. Again if it is the next bit is 1, it should be a high to low. So here I will show, okay, wherever the transaction will be taken place. So here see this stage it should be a high to low. Okay, and here, okay, it should be a low to high. Okay, and until that it is going to follow the previous output. See here it should be a high to low, and this will be a low to high. So this is the low to high. So finally we have to join lines together. We will get the output of the differentiate Manchester. So this is what the complete line coding schemas.